In the previous lecture, we set up the report definitions, report monitors, and the report files. And in this lecture, we set up the convergence monitor, or we call them the residual plots. These plots usually show that the how solution is converging from one iteration to the another. And from the fluent point of view, the solution is to be assumed when the plot has decreased to some value, and then it stays at the same level, maybe with some wiggles. And usually we assume the solution has been converged when this level is at 10 power minus 4, and sometimes we also assume solution is converged when it's at 10 power minus 3. And to achieve minus 5 or minus 6 is very much difficult, but it's possible for simple cases. And 10 power minus 8 is the maximum possible level you can attain on any practical problems. So based on the residual plots and the convergence of the parameters of interest, such as the left and right coefficients, as we set up in the last lecture, they tell us about the solution convergence. So just based on the residual plots, you cannot decide about the solution converged or not. So combining with when the drag has been reached to some value, it's not changing. Similarly, the lift coefficient is not changing its value from the one iteration to the another iteration. We will assume solution has been converged. So that's why we have to set up this parameter also, these plots also. So from the monitors, double click on the residual plot and then change the default settings of the continuity x and y and z velocity, or for 2D cases only it's x and y, and also the turbulence parameters, change them to 10 power minus 6. Although we cannot achieve this level, but it means that the solution will continue to run for the number of specified iterations, or if luckily we get this level of the convergence, the solution will stop before the prescribed number of the iterations. After that, click on OK. So on the fluent, double click on the residuals and put the value as a 1 e power minus 6. By default it's a minus 3, so you can copy this value and paste in the all other fields. In this way you can set up these all fields with a single command. So just one time copy and then paste in the every field. You can also choose to not monitor the convergence based on the residual plot. So if you just click on none, the solution will never stop. This will only stop when the number of iterations has been reached. Then click on OK. So now we have successfully set up the residual plots, and based on this we will see how solution is converging when the solution will run in the fluent.